Alright, so before we continue with GANs, I promised to give a little intermezzo on game theory, and more specifically on the Minimax problems. Yeah. So here you have the objective function of our GAN, and you see there is conflicting goals, especially for what this term is concerned. Yeah. So basically how we see this is we have two players A and B, and A wants to end up as high as possible and B wants to end up as low as possible. And I've drawn the tree here, and here I have numbers from 0 to 50. Yeah? So B wants to end up here, A wants to end up here. A will open the game, so the first move is by A. And each of these players, A and B, have two plays. Alright? Now you can prove that every Minimax game has a solution. Yeah? Solution means that you will converge to certain number or certain outcomes. And this type of equilibrium, we call it a Nash Equilibria in game industry. So let us take this tree here, and let's take a look here. We know that B is going to choose at this point, and we also know that B will choose the lowest. So in our case, B will choose 5. All right. Here the same thing. B will choose the lowest. Will choose 14. Here the same thing, B will choose 6, here B will choose 2, B will choose 4, B will choose 9, B will choose 1, and B will choose 0. So all the numbers that I barred are out, yeah? So they don't count anymore. So now we go to the next level, and here it's A's turn. Right? So A now here sees these two numbers, and A wants the largest. Yeah. So A is gonna choose 14, so I bar the 5. Here the same thing. A is gonna choose 6, so I bar the 2. Here the same thing. A is gonna choose between 4 and 9, so it will choose 9, and between 1 and 0 it will choose 1. So you see already the 0 is gone and the 15 is gone. So whatever happened, these two won't meet their ultimate objective. So then we're back at B, and B looks now to this tree. It has two choices, 14 and 6. Well, B will choose 6, definitely. And here the same thing. So B has a choice between 9 and 1. So B will choose 1. Alright? So now we're back at A at the top. And I only have two numbers left here. I have 6 or 1. Since A makes the choice, this will be your final outcome. Yeah? So the path will be this one. Here we go. Down here, down here, down here. Yeah? So this will be your path. And no matter what you do, you will always end up there if A and B play their best game. Alright? So if they don't deviate from their own objective rules. Alright, so this is basically what game theory says. We have a min-max problem here. Although in reality there's lots of issues with convergence. Yeah? But I just wanted to give you a feel of how a min-max problem is defined.